بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Today inshallah we are going to talk about access control, that is in the book in chapter 4. So what is access control? If you would like to link it with what we have discussed last chapter, which is about user authentication. User authentication, as we said, that it is the first step to protect the system. It is the first line or the front line defense, the authentication. What is the second step, or the second A, is the authorization. If you remember, we said authentication, then authorization, and based on robust and resilient authentication and authorization, we will be able to have strong accountability or auditability. Okay, so this is the second step, which usually comes immediately after the authentication. Authentication, when we authenticate the user, verify that this is the user that has the authority or the privilege, the permission to access the system. Consider it as the first main gate. Okay, then after the main gate, we need to conduct authorization, or in other words, access control, where we are going to allow to permit this legitimate user to go, to access, to do, to use within our physical premises or digital premises. Okay, so access controls principles defines computer security as measures that implement and assure security services in a computer system, particularly those that assure access control service. So we need to, as you can see here, between the user would like to access system resources. Okay, he needs as the first step to authenticate himself using authentication functions, any authentication method that we talked about, knowledge based, token based, or even biometric based. So this is the first A, authentication. After that, after entering the system, generally at the main gate, now there is an access control function that will see and check the authorization database that is already stored about this legitimate user, to which resources he can access and to what level, to which depth is he able to access specific databases, and for as a read only or write and read, or authorize others to access these resources, and etc. If we have strong authentication function and authorization access control function, we will be able to have we will be able to have a strong we will be able to have strong we will be able to have strong auditing here. Okay, okay. So what are the different policies for access control? There are different policies. These are the main four policies that we can apply for access control. We can apply one of them, two of them, or a set of them. The first one is discretionary access control. Discretionary access control. As an acronym, it is DAC. AC, access control, D, discretionary. From its title, discretionary, this is meant to be that it is based on the decision of the system administrator. Simply controls access based on the identity of the requester and on the access rules. So it is different from one to one, even though that, for example, both employees has the same position, same title, but the system administrator or the admin is going to grant, let's say, grant permissions to employee A different than permissions granted to employee B. Okay, so there is no specific rule for that. Mandatory access control, from its title, the MAC, it is based on comparing security labels with security clearances. Usually it comes with the sensitive systems or critical systems, like such as military. So based on what is linked with that position of that place, so they will be granted the permissions, and usually its updates is very limited. The third one is the rule-based access control. Rule, not role. The rule-based, it is called, or it is called attribute-based. But before that, let's talk about the role-based access control. Role, or in other words, the position-based access control. So it depends on the role of the user. So there is a predetermined roles or positions on a specific organizations. If the one that will be assigned to the position or the role of managing director, he will have access to everything in the system. For example, if he is a deputy, he will be able to access this and this and this. If he is chairperson, this and this. If he is a faculty member, if he is a student, and so on. The fourth one is the attribute-based access control, that controls access based on attributes, features, characteristics of the user. This is these are the first attributes of the user, the resource to be accessed, and the current environmental conditions. So it might be different for the same user to access the same resource, but the environment will be different. For example, I will be able to access a specific system while I am at home or within the organization premise, but I will not be able to access it while I am on another location or another even country, and so on. Okay, as you can see here, that discretionary first is the least with in terms of efforts and resources needed is the mandatory access control, but it is not flexible. The discretionary is beneficial in some environments, especially if the organization has very low or limited number of employees, so it will be easy to assign different permissions or privileges or access controls to different staff based on their need and when needed or when requested. But if the organization is getting larger, so there will be a room for potential mistakes. By mistake, a permission will be taken out from one of the staff that it is necessary to have it, or the opposite, one permission will be added mistakenly to a staff or an individual that is not supposed to have it. The role-based is good for large organizations with a large number of employees, and usually there is no individual or there is no need for new access control settings for each individual. Just whenever we have a new individual, a new staff, we need just to assign it to one of the roles on the system, and then it will be decided, or he will take the permissions for that role. Attribute based is more modern, and it is getting more useful nowadays, as it is more flexible and it is more realistic to the real need and real use than the others. Okay, so as you can see, on access control generally we have three three you have three factors, let's say, or three elements, three basic elements. One of them is subject. Subject is the user or the system that is capable of accessing objects, accessing other resources. So it can be an individual, a human, or a system. It has three classes: owner, group, or board. The object to be accessed, a resource to which access is controlled. And It is usually an entity used to contain and or receive information. So this subject is accessing this object based on the pre-subscribed or described access rights, access permissions. Describes access rights, describes the way in which a subject may access an object. This could include reading access right, writing, executing, deleting, creating, search. You may remember these access rights from the database course. So we have subject, object, and access right that control the access between the subject and object. We talked about each one of these, the discretionary access control, but let's see if there is any addition that we need to add or we need to emphasize on. Usually the discretionary access control, it is given as a matrix with 2 dimensions. Each entry in the matrix indicates the access rights of a particular subject for a particular object. So we have the subjects, user A, user B, user C, and we have file 1, file 2, file 3, and file 4 as objects, resources to be accessed. So this is the matrix. User A, for example, has the right to own, read, and write file 1, but he doesn't have any right to file 2 and nor file 4, but file 3 has this own read write. User B has only read file 1 and only write to file 3 and so on. Okay, so this will be like the authorization database. After the subjects, after getting authenticated to the system, now the system will check if this is user A and he is able to access file 1 and 3 with these access rights only, nothing else, and so on. This is another structure for the matrix. So this is the authorization table that can be created based on that matrix. So see that it is divided here to be put on a table. Subject A, he has on read write for file 1, on read write for file 3, nothing else, and so on. So it is the same thing that here on the structure and on the matrix here, but it is in a format of a table or a database, based on which the access control function will get the access control information from before taking a decision to grant access to the resources or not. This is an extended access control matrix. The subjects and the objects, some of the subjects might be able to access different than files, processes, and disk drives, and others, printers, for example, and so on. Here, if we can use the access control commands, that is similar to what we used to use for databases like Oracle or SQL, MySQL, and etc. it is for granting these access controls to these objects, and so on. But you don't need to know exactly these commands or to memorize them. Just utilize them to understand the concept. Okay, these are the protection domains. Protection domains that access control is used for is to set of objects together with access rights to those objects. It will provide or offer more flexibility when associating capabilities with protection domains. There will be an association between a process and a domain that can be static or dynamic, and so on. This is an operating system specific that you don't need to, but you can utilize to understand it more. If we are in the normal situation, we will be able to try some of them in the lab. See, this is read and write, and so on. This is the owner will have read and write, but the group will have read, others nothing, and so on. With regard to the role-based access control, so as you can see here, we have a user that this user and this user both has assigned the role 1. Role 1, like for example, let's say a student. Both of these users are students. Role 1 is a student, so the student will be able to access this resource only. If we have another one here, we may have one person that is assigned to different roles, like this one has assigned to the role 2 and role 3, like for example, he is a faculty member and he is at the same time the college deputy, so he will inherit both roles and both privileges and access controls for both roles, and so on. As you can see that it is easier than having the discretionary access control by setting specific separate permissions for this user and different ones for the other user, and etc. Just assign him to a specific role, and before that we need to assign or specify the rights or permissions, privileges for each role just at the beginning, and then after that we can put the users under any of the roles. This is an example for the role based. We have roles, as you can see here, not subjects themselves, and another table for each user. It is or he is or she is under which role. The first table, the user and which role, and here the other table, the roles with the objects. So there will be like a relational relation between them, between these two tables, with of course as you know from databases, with primary keys and foreign keys here to link both of the tables. So our back role-based access control, we can have, for example, role hierarchy. These are some of the practices that we can set, for example, specific roles to avoid or minimize, mitigate mistakes, errors. Some of the roles, for example, can be constrained by some of the constraints, some of the limitations. Like for example, setting a specific number for a specific role. For example, the managing director will be only one. We cannot have two managing director in the college. So to avoid assigning by mistake the managing director permissions to a staff, whereas we are already we have already an MD and so on. Sorry. So we can set some of the models here with specific hierarchies and constraints. This is an example of, so we have hierarchy, we have two project lead, so there cannot be a project lead 3, and under each one of them there are other roles. Each of these roles has its own permissions, its own access rights. So whenever we put any of the individuals under any of these roles, he will inherit that role access rights. So these are the types of constraints that can be applied and enforced on the ABAC role-based access control. What is the benefit from them is to provide a means of adapting role-based access control to the specifics of administrative and security policies of an organization. So based on the security policies of the organization, there will be a statement, for example, for the number that can be assigned to each of the roles and so on. So a defined relationship among roles or a condition related to roles. The types here, for example, we have 3 means or 3 types of constraints for role-based access control. Mutually exclusive roles, where a user can only be assigned to one role in the set. Only one role for each user. So either during a session or statically. Any permission or access right can be granted to only one role in the set. Cardinality, this is the maximum number with respect to roles. For example, maximum number is 1 for MD, 3 for deputies, 10 for chairpersons, and so on. Prerequisites. Sometimes there is a prerequisite for a specific role that dictates that a user can only be assigned to a particular role if it is already assigned to some other specific roles or specified roles. For example, an academic department chairperson cannot be assigned that position on that role before being already a faculty member in the college. So we cannot have an admin guy with admin role to be an academic chairperson, or we cannot have a student with the role of a student to be or to take or to be granted the role of chairperson, just to avoid any mischief, any mistakes, or any even deliberate intentional illegal action. So the attribute based access control, that we said that it is based on the subject and the object to be accessed as well as the environment. So it is benefit that it can define authorizations that express conditions on properties of both the resource and the subject. It is flexible, from which its power is clear. Main obstacle to its adoption is in real systems that there has been concern about the performance impact of evaluating predicates of both resource and user properties for each access. So if we set it based on the environment, based on the location of the access request, what about if the location, the GPS of that surface or that device is not working properly? The user or the legitimate user, the authorized user, might be locked out. So the web services have been pioneering these things using extensible access control markup language, XAMPP. There is considerable interest in applying the model to cloud services. So it provides flexibility and even more reality to apply access control to cloud services. The attribute or ABAC, attribute-based access control, as we said, the subject attributes, object attributes, and environment attributes. The subject attributes, a subject is as the main definition of it, an active entity, either individual or a system, that causes information to flow among objects to change the system state. Attributes define the identity and the characteristics of the subject. The object attribute or the resource to be accessed is a passive, usually a passive information system related entity containing or receiving information. Objects have attributes that can be leverages to make access control decisions. Environment that we mentioned can be operational, technical, and even situational environment or context in which the information access occurs. As we said, that based on the day or night, on the timing, based on the location, and so on. These attributes have so far been largely ignored in most access control policies, but with the new advancing and emerging technology, it is being more popular nowadays. So the ABAC, it is distinguishable because it controls access to objects by evaluating the rules against the attributes of entity, operations, and the environment relevant to a request. It is flexible, but it needs careful implementation. Systems are capable of enforcing any of the other access control policies, like discretionary or role-based or mandatory consents. It relies upon the evaluation of attributes of the three factors or three elements that we said: subject, the object, and the formal relationship or access control between them. It allows an unlimited number of attributes to be combined to satisfy any access control, but again, this settings, configurations, and implementation should be considered and set very carefully. So the access control policy here, we have as an example scenario here for ABAC, we have a subject that would like to access an object here. Number one, a subject, and three, an object. In between, we have access control elements. We have subject attributes like name, clearance, affiliation, and role, and so on. We have the objects attributes like the type, the owner, who's the owner, the classification, whether it is sensitive, critical, confidential, and so on, and the environmental conditions. Based on that, and based on the access control policy here, a decision will be taken with specific access rights to be enforced for that subject to access this object. Okay, this is a more strong relationships that you can visualize here, or you can study here to understand and visualize the process. See that before the access control here, the subject needs to authenticate himself using identity, credentials, network access, and others. After the decision is taken to be rejected, so nothing will go further. But if it is accepted, so the access control decision needs to be taken and enforced to the object. So the policies here, the attribute-based access control policy here, to be set, configured, and enforced based on it. It is a set of rules and relationships that govern allowable behavior within an organization based on the privilege of subjects and how resources or objects are to be protected under which environment conditions. So it is the general rule, the general policy, based on which the access control decision will compare the results with and will take a decision. It is typically written from the perspective of the object that needs protection and the privileges available to subjects. The privileges, permissions, represent the authorized behavior of a subject and are defined by an authority and embodied in a policy or in this policy. Other terms commonly used instead of privileges are rights, as we said, access rights, authorizations, and entitlements. So we have, these are synonyms: privileges, permissions, access rights, authorizations, entitlements, etc. To have all of these together, all the authentication mechanisms and the authorization one together, we can have a comprehensive management system called ICAM, or Identity, Credential and Access Management, or sometimes it is IAM, Identity Access Management. It is a comprehensive approach to managing and implementing digital identities or associated attributes, credentials, and access control. It has been developed by the US government initially, but it is applicable not only to government agencies, but also it also may be developed by enterprises looking for a unified approach to access control. It is designed to create trusted digital identity representations of individuals and even non-person entities, NPEs, non-person entities, like systems that is authorized to access other systems. As we said, for example, before, like ABSHIR, for example, ABSHIR system of the Ministry of Interior here in Saudi Arabia has the authority to access the systems of passport agencies, of traffic agencies, and so on. So it is also designed to bind those entities to credentials that may serve as a proxy for the individual. It uses the credentials to provide authorized access to an agency's resources. So this is an example of a comprehensive, complete ICAM, Identity, Credential and Access Management. There will be credential management that will have the data of the sponsorship, enrollment, credential production, issuance, and even credential lifecycle management, like for example the expiry the date or expiry period for each credential to be renewed every month, every 3 months, etc. Identity management, attributive, background investigations, digital identity lifecycle, and so on. We have identity management here to manage the provisioning and deprovisioning between the access management, identity management, and credential management. It has resource management, physical access, logical access, policy management, etc. And on top of them, we have identity federation, external agency, state or local government, business, partner, citizens, and so on. Federation, I don't remember whether we have defined it in the previous chapter or not, but federation, let's state first before it, single sign-on. Sometimes it is written as an acronym SSO, single sign-on. Single sign-on is when there are different systems within the same organization. Whenever you log in, you authenticate to one of them, so you will be able to access the others. Okay, let's say, take Google as an example. Whenever I access and authenticate myself, enter the username and password for Gmail, for example. So we will be able to access the other services from Google, like Google Forms, Google Drive, and others, from that first and single sign-on login. Okay, but the identity federation, it is similar concept, but it is further. It is not only within the same organization, but there will be different organizations or agencies. That's why there is external agency here, that they have a pre-agreement between them to authorize anyone who gets authenticated, get verified from one of these organizations to access the others. As an example, we have, for example, before the acquisition, the YouTube, for example. If you would like to access it, to access your channel, before in the past, you have to create your own account in YouTube. But now there is an agreement, I'd say just literally, or not literally, before the acquisition of YouTube by Google. Before that, if and even now, if you would like to access your YouTube channel after being logged in on Google, so you will be able to directly go there. You may notice that sometimes in some websites, whenever you try to access one of them for the first time, for example, you will be asked, would you like to use your Facebook account, your Google account? So this is like the identity federation. So your identity is being federated, being traveling with you between different entities, different organizations, and so on. So the single sign-on within the same organization, and the identity federation is between different organizations. So identity management in general is concerned with assigning attributes to a digital identity and connecting that digital identity to an individual or non-personal individual entity. Sorry. The goal is to establish a trustworthy digital identity that is independent of a specific application or context, that can be traveled with you logically wherever you try to access on the cyberspace. Most common approach to access control for applications and programs is to create a digital representation of an identity for the specific use of the application or program. Maintenance and protection of the identity itself is treated as a secondary to the mission associated with the application. The final element is lifecycle management, which includes mechanisms, policies, procedures for protecting them, controlling access to identity data, revocation of enterprise, techniques for sharing between different applications and with other organizations as well. So the credential management, now we are still talking about the blocks, these blocks. The credential management here, it will contain the management of the life cycle of the credential. For example, credentials are smart cards, private or public cryptographic keys, and digital certificates. It may encompass 5 logical components. Please. Okay. Access management deals with the management and control of the ways entities are granted access to resources. It is managing the access rights, simply. It may be internal to a system or an external element. It covers both logical and even physical access. Its purpose is to ensure that proper identity verification is made when an individual attempts to access a security sensitive building or computer system or data. They have three support elements that are needed for an enterprise wide access control facility: resource management, privilege management, and policy management. You can read through each one of them. The resource, it is directly concerned or related to the resource itself and to what extent that we are willing to grant access to others in general. The privilege management concerned with establishing the and maintaining the privilege attributes that comprise an individual's access profile. Privileges are considered attributes that can be linked to a digital identity. Policy management, the general set rules that governs what is allowable and prohibited in an access transaction. The identity federation is the one that we elaborated. Terms used to describe the technology, standards, policies, and processes that allow an organization to trust digital identities, identity attributes, and credentials created and issued, this is the key, issued by another organization, not the same organization. So it addresses two questions. How do you trust identities of individuals from external organizations who need access to your systems? So trust between different organizations is very important here. And the second question is, how do you vouch for identities of individuals in your organizations when they need to collaborate with external organizations? Are you going to pass all the credentials data or only to pass the decision, for example, and so on? So this is which is usually needed for identity federation. Usually there is a need for a third party, which is usually identity service provider, to liaise between the user and the relying party, or the objects to be accessed, the resources to be accessed. And between them there is terms of service agreement. These are some examples of the protocols or frameworks for identity trust. Just you need to know their examples. OpenID is the most common one or the most famous one, and open standard that allows users to be authenticated by certain cooperating sites using a third-party service. And others, there is one that is not mentioned here, is Shibboleth. So here is an illustration of how the identity attributes is exchanging and what is exchanged. There is an example for the functions and the roles here that can be applied and utilized for that purpose. So we have functions and officials positions. We have a second another table for permission assignments based on the rules, and the PA with inheritance here. There is another illustration. For example, the human resources departments, the users, and these are their roles, and this is the cardinality. These are the application administration, applications and admin access rights, and the authorization, administration role and application. These are only examples, they are not mutually exclusive. Okay, so we have come to the end of this chapter. We talked about the authorization in general, access control principles, the main elements, the different policies of access control, and the identity, credential, and access management, in addition to the trust frameworks that we mentioned them just briefly. Thank you very much.